All right, so today we're taking a deep dive into something pretty awesome. AI that can write
Yeah.
entire lines of code and like right there in your IDE. We're talking about JetBrains' full line code completion, and we've got an inside look at how they pulled it off.
Yeah, it's a pretty impressive feat, when you think about it. Most AI coding tools out there rely on the cloud, which, well, it presents a whole bunch of challenges like privacy concerns and needing a really strong internet connection, just to name a few. And not to mention, those cloud-based models are massive. You don't really want that taking up all your resources on a regular laptop.
Exactly. So JetBrains took this challenge head on and created FLCC, which, well, their goal was to bring that power of AI code generation right to your desktop, make it run locally, and most importantly, fast. And lucky for us, they explained everything in their research paper.
Yeah, one of the first major obstacles they had to tackle was the data. To train a powerful AI, especially on code, you need a massive amount of data, and it has to be high quality. You just can't go around grabbing random code from the internet. Licensing issues and just the overall quality of that code can be a nightmare.
Makes sense. You can't just feed any code to the AI, right? So how did JetBrains solve this?
So they went with a subset of what's called the stack. And this thing is huge. It's unbelievably huge. We're talking over 6 terabytes of source code and in almost 400 programming languages. But the key here is that it's been carefully curated to only include code with permissive licenses. So they avoided all those legal headaches right from the start.
That's smart. But isn't code by its nature pretty clean? I mean, what other kind of cleanup did they have to do to the data?
Oh, you'd be surprised. Even without comments, you find all sorts of weird stuff in code. Random characters, strange formatting, you name it. These little quirks, they can really mess up an AI's training. So JetBrains did a deep clean of all that data, removing anything that could potentially throw the AI off track.
So it's kind of like teaching a new language to someone. You want to make sure the examples are super clear and consistent.
Exactly. And to make the training even more effective, JetBrains took it a step further. They made sure the code they used reflected real-world coding habits. For instance, they would randomly drop import statements, which is something developers do all the time. That way the AI gets a more realistic view of how code is actually written.
Wow, that attention to detail is incredible. So they've got this massive, clean data set. Now, what about the AI brain itself? What did they use for that?
Well, they chose a LLaMA-like architecture. And they chose this because it's known for generating high-quality results, and it does it quickly. They trained this thing on 8 H100 GPUs. To give you some context, H100 GPUs are some of the most powerful processors out there, specifically designed for AI.
Okay, so we're talking top-of-the-line AI being trained on a mountain of data.
Yeah.
But you mentioned earlier that these AI models can be huge. How in the world did they manage to get this thing to run on an average computer?
Well, that's where things get really interesting. They used a technique called quantization. Imagine taking a high-resolution image, and then you compress it down to a smaller file size. You might lose a little bit of detail, but the overall image is still there.
So they shrunk the model down without losing too much of its smarts, right?
Exactly.
Yeah.
It was all about finding that sweet spot between size and performance. They experimented with different quantization techniques, things like 4-bit and 8-bit quantization.
What's the difference between those?
Well, it comes down to how much information you're keeping. Think of it like colors. 8-bit color gives you 256 shades, while 4-bit only gives you 16. So 4-bit is smaller, but you end up sacrificing some color depth.
I get it.
Yeah.
So they had to find that perfect balance where the model was small enough to run locally, but still powerful enough to be useful. Did they manage to pull it off?
They did. It was a success. The result is an AI that's compact enough to run on your computer without any noticeable lag, which was a major goal for JetBrains. But getting the model to run smoothly, well, that's only part of the story. They also had to figure out how to make the AI truly understand code, especially when you're typing in the middle of a line.
Yeah, I can see how that would be tricky. The AI is trained on whole words, but your cursor could be anywhere.
Precisely. And that brings us to one of the most ingenious parts of this whole system, what JetBrains calls token healing.
Token healing, huh? Sounds kind of magical. How does it work?
It's pretty clever, actually. Let's say you're typing the word variable, but your cursor happens to be right after the V. So the AI sees V and variable as separate things, separate tokens, and that doesn't really make sense to the model, so it needs a way to understand what you're actually typing.
So how did JetBrains fix this?
Well, their solution is pretty simple, elegant even. What it does is the AI actually backtracks. It goes back to the beginning of the token, in our example, the beginning of the word variable. And it does this before making any suggestions. That way it has the full context of what you're working on.
Okay, that makes a lot of sense. It's like the AI takes a step back to see the bigger picture. But even with this token healing thing, I mean, are there any concerns about the AI just generating way too much code?
Oh, absolutely. You definitely wouldn't want the AI to just keep spitting out code forever. So JetBrains, they had to come up with a solution for this too. They actually built in logic that helps the model understand when a line of code is complete, logically complete.
So they basically taught the AI when to stop, huh?
Mm.
How did they do that?
Well, they trained it to recognize patterns in code that usually signal a complete thought. For example, let's say you're writing a function call. The AI is going to recognize that closing parenthesis as a clear signal to stop generating code.
That's pretty smart. Okay, so they've got this data all figured out. They built a super powerful model. They taught it to understand context and even when to stop. So how did they actually get this whole thing to work inside an IDE?
Ah, that's a great question. Because you see, you can't just drop this massive AI model into your IDE. Everything would come to a screeching halt.
Right, that wouldn't be very useful.
Exactly. So what they did was they created a separate server. The server lives on your computer and handles all the heavy lifting for the AI. And they wrote this server in C++.
So there's like a dedicated AI server running in the background.
That's right. And to run the AI model on the server, they chose LLaMA.cpp, which is known for its speed and efficiency. And the server, it communicates with your IDE through something called gRPC.
gRPC, what's that?
Well, gRPC is basically a modern communication system. Think of it as a super fast messenger that lets different programs talk to each other. It's perfect for this kind of setup because it lets the AI server and your IDE exchange information quickly and without any hiccups.
Okay, so the AI does all the work on the server, sends the suggestions back to the IDE through this gRPC thing, and everything runs smoothly. Are there any other optimizations they made?
Yeah, they've got one more trick up their sleeve. They use something called smart caching.
Caching. Isn't that what your web browser does to make websites load faster?
Exactly, same principle here. When you're coding, you often work within the same files and functions. So JetBrains, they cleverly cache the AI's calculations. This means it doesn't have to redo the work every time you need a suggestion.
Ah, so it's like remembering the answer to a problem instead of solving it over and over again. That's a clever way to speed things up even more. But with all this AI power running in the background, I have to ask about security. I mean, what's stopping the AI from suggesting something malicious, like deleting files or leaking sensitive information?
That's a crucial question and a valid concern. And let me tell you, JetBrains took security extremely seriously. They go into great detail in their paper about all the safeguards they put in place. They have multiple layers of filtering to prevent the AI from suggesting anything dangerous, like harmful commands or leaking API keys, even offensive language. All of that is filtered out.
So they make sure that the AI is a helpful partner, not a security risk.
Exactly. That was the goal. They wanted to ensure that the AI is both powerful and responsible.
This is all great in theory, but how well does it actually work in practice?
Well, that's the real test, isn't it?
Did they do any real-world testing with actual developers?
They did. They conducted extensive A/B testing. They had one group of developers use FLCC and another group use standard code completion. And then they compared the results.
What did they find?
The results were pretty remarkable. The developers who were using FLCC, they were able to write significantly more code. We're talking a 1.3x increase in productivity specifically for Python.
Wow, that's a huge improvement. But did they measure anything else besides just the amount of code written?
Oh, yeah, they didn't stop there. They tracked all sorts of things, like how often developers accepted the AI suggestions, whether they deleted any of the suggested code, and how long it took them to complete their tasks. These metrics gave them a really good understanding of how helpful and efficient FLCC actually is in a real-world setting.
So it's not just about writing more code, it's about the quality of that code and how well the AI fits into a developer's workflow.
Precisely. And the results clearly show that FLCC isn't just some fancy tech demo, it's a tool that actually makes a tangible difference.
This is incredible. And what I find really cool is that JetBrains shared all of this in their research paper. They were very open about their methods, the challenges they faced, even the things that didn't work out.
Yeah, it's a very transparent approach, and it's great for the AI community as a whole. Other researchers and companies can learn from their work and hopefully build even better tools in the future.
This is definitely a game changer. But it feels like this is just the beginning, right? We're talking about AI. that can generate entire lines of code. I mean, what does that mean for the future of software development?
Yeah, it does feel like we're moving into a whole new era of coding, one where AI isn't just a tool, but more like a partner, you know?
Yeah, like a coding buddy.
Yeah.
And what's really key here is that this partnership, it's got to be built on trust. And JetBrains really focused on building an AI that you can rely on, not only in terms of the code it suggests, but also how it integrates with your actual workflow.
And they didn't just assume it would work seamlessly. They went out and got that real-world data from real developers
Mhm.
to see how FLCC actually performed, out in the wild. And that's what I think sets them apart from a lot of companies, the ones that just like hype up the latest AI without really thinking about the user experience.
Totally. It's not enough to just have some fancy AI model. You got to make sure it actually helps developers, makes their lives easier,
Yeah.
not get in the way or make things more complicated. It's like they actually took the time to teach the AI, not just about code, but about how developers think and work.
Yeah, exactly. And they even went a step further. They created a special API specifically for inline code completion. This means other companies can build their own AI tools that will actually work well with FLCC.
So instead of having a bunch of different AI tools competing with each other, we could have like a whole ecosystem of intelligent assistants all working together.
That's the vision, a truly intelligent and intuitive experience for developers.
So let's bring this all home. What does this mean for, the average coder out there?
Well, I think it means we're on the edge of a real productivity revolution. The way we write software is going to change, and change in a big way. And what JetBrains has shown us is that it is possible to create AI tools that are not only powerful, but also reliable and genuinely helpful.
I'm really excited to see where all this goes. It feels like we're just scratching the surface of what's possible with AI and software development.
Absolutely. This deep dive into FLCC has been a fascinating glimpse into the future of coding.
So to all the coders out there, stay curious, keep your minds open. The AI coding revolution is here, and it's going to change everything.
And on that note, we'll leave you with one final thought. If AI can write code, what else can it create? What other creative tasks could be transformed by this technology? The possibilities are pretty much endless.